Greetings to everyone. My name is Eder Alvarez. I'm from the Universidad Autónoma de San Luis Potosí, Facultad de Ciencias, and this is my presentation about the green synthesis of silver nanoparticles using Garambullo, characterization and application in orthopedic cast. The Myrtillocactus geometrizans, also known as Garambullo, is a plant that belongs to Mexico. To make the extract, the Garambullo was used in 4 different ways: fresh when it's red and ripe, dehydrated, green one, and the Garambullo stems. 2 and 4 grams of each forms were weighted and crushed, except the stems, and then these were boiled for 5 minutes. Once cold, it was filtered and placed in a plastic container. The extract must be at room temperature, and after preparation it is kept refrigerated for future uses. For the synthesis of silver nanoparticles, it was carried out at a concentration 10 to a power of -3 molar. Once the calculations were made, 0.0042 grams of silver nitrate were weighted for 25 milliliters of solutions. Once dissolved, the extract was added, and immediately, using a pH meter, it was raised to a pH of 11 with ammonium hydroxide or sodium hydroxide, instantly turning black. Tests were also carried out without modifying the pH. Using Vis-NIR spectroscopy, the plasmons of each of the 72 samples were taken every 15 minutes up to 1 hour. We can see the highest peak in 420 nanometers in all cases. This tells us that they are within the wavelength ranges of silver nanoparticles. The plasmons of each synthesis were compared with sodium hydroxide, ammonium hydroxide, and without changing pH, choosing the best for the following measurements. With the dynamic light spectroscopy, the following sizes and zeta potentials were obtained, noting a smaller size in the red Garambullo and in the stem one. As the most common bacteria in an exposed wound are Staphylococcus aureus and E. coli, they were used to measure the minimum inhibitory and bactericidal concentration of the synthesis. Those with a smaller size were chosen, highlighting 13 samples using the microdilution method. For the MBC, the best column was chosen and 2 cells were inoculated before and after the MIC. They were seated in a petri dish and incubated for 24 hours at 36 degrees centigrade, resulting in the MBC. Once the calculations were made, it was observed that in the case of Staphylococcus aureus, those with a better MBC and MIC are the next one. Just as the same with E. coli, but adding 2 EG-SNA 2.5. To make the plasters in accordance with the AS-TMD 1161s and to have a higher density, tubes of 4 and 6 layers were made. For this, the length of each bandage and its weight were measured. Proceeded to wrap a glass tube with a diameter of 2 centimeters. The padding method was carried out. They were typed in the synthesis for 3 to 4 seconds. The excess was removed manually and proceeded to wait. It was left to dry for 72 hours and the mechanical tests were carried out. For the mechanical properties, the 3-point test was used, which consists of exerting pressure on the middle of the cylinder until reaching its breaking point. Pressure, maximum pressure, and deflection were measured and calculations are made to obtain flexural stress, flexural strain, absorption, and evaporation percentage. We perform the calculations with the following formulas. Having that, for the 4-layer cylinders, This one has the best properties, and those with 6 layers, this one has higher pressure and breaking load. The next one has a higher percentage of absorption and evaporation. This one has higher bending deformation, and the last one has lower deflection. For the Kirby-Bauer test, the ones with the best results in microdilutions were used. They were made with different proportion of grams of plaster and milliliters of syntheses. The same was done with Staphylococcus aureus and E. coli, having a graded inhibition halo in a 1-to-1 ratio for both cases. In conclusion, we can say that green synthesis is not accurate. It depends on the plant or fruit, the growth medium, and the properties of the soil. The size of the nanoparticles changes. Those that had a smaller size were those synthesized by fresh and dehydrated Garambullo in the second attempt. The largest nanoparticles were obtained again from dehydrated Garambullo for months with more than 500 nanometers. The extract bactericidal test was carried out, obtaining that it is null. We had 4 plaster samples with the best characteristics, one made with green Garambullo and the other 3 with fresh Garambullo, all with sodium hydroxide. I finished this presentation, and if you have any question, don't hesitate to publish it. I will gladly answer it. Thank you.